Cool. Okay. Well, thanks everyone for joining. Today we're going to sort of briefly cover AdoptOpenJDK. We're going to do a little bit about it, sort of what its roots are, where it is today. But before I sort of dive into any of the details, firstly, I'd like to introduce my esteemed friend and colleague, Hendrik.
Hey. So I have some sound problems. So after the slide, I will go away, restart my PC, and be back in 5 minutes. At least introduce myself. I'm Hendrik from Germany. I live in Dortmund, and do a lot of Java-related stuff. So I'm one of the co-founders of the company Karakun. I need to switch this off. I heard me twice. Sorry. So I'm one of the co-founders of the company Karakun, and I work on Java. So I do like Java consultancy on architecture in Java projects. And next to this, I do a lot of community-related work in the Java ecosystem. I'm, for example, was part of the Java Bean validation expert group for the JSR, and did a lot of talks and sessions around the world. For example, at JavaOne in San Francisco, and based on this, I received the JavaOne Rockstar Award 2 times. And I'm a Java champion since some years, and since last year, I'm really happy to be part of the AdoptOpenJDK team, and trying to push like Java as an open source runtime, and as an open runtime, and as an easy to use and get runtime forward together with George and others. That's about me.
Cool. Thanks.
Leave the meeting and restart my PC and hope that I have better sound afterward, because otherwise I hear everything like 2 or 3 times. So
Lovely.
5 minutes.
Thank you, Hendrik. Cool. Okay. Well, thanks for the interesting intro. So as Hendrik mentioned, my name is George Adams. I'm a Java program manager at Microsoft. I'm also coincidentally one of the AdoptOpenJDK co-founders. And I sit as the chairman on the technical steering committee there. I also sort of like to play around with a few other reasonably large open source projects. I'm a core collaborator at the Node.js Foundation, and I'm also a bootstrap team member of the OpenJS Foundation. So to kind of quickly go through what we're going to cover, we're going to go over the terminology. What I mean by that is there's all sorts of strange terms and acronyms in the Java ecosystem. And so I want to clarify those before we start mentioning them, so that hopefully things are a little clearer. We're going to have, hopefully, Hendrik go over the OpenJDK workflow, but otherwise I'll cover that. And we're then going to do vendor distribution and the differences between each vendor. And then we're going to delve straight into AdoptOpenJDK, cover some of its history. We'll talk about Adoptium. I'm not sure how many people have seen the recent announcement of the move, but we'll cover that. And then we're going to talk about build and test and the sort of roadmap going forwards in the project. So to dive straight in, let's cover terminology. So when we talk about terminology, we first refer to the term OpenJDK. To clarify, OpenJDK is not a binary. You don't download OpenJDK. OpenJDK is a source-only project, and it is the reference implementation of the Java SE standard. So what I mean by that is OpenJDK is maintained by multiple vendors, including Oracle, Red Hat, SAP, but there are no binaries that come from that. You can get an OpenJDK binary, which is a JDK binary built from an OpenJDK source code. So, for example, you could download a Java binary from Oracle. You could download a JDK from AdoptOpenJDK. And they, of course, are OpenJDK providers. So by provider, I'm meaning a vendor who provides an OpenJDK binary. So I hope that's nice and clear. There's this kind of very distinct difference between the three of them. So I'm hoping that Hendrik will be back in a minute, but for now, I'll get started. So for the last kind of few releases, things have changed quite a lot. I'm hoping that most of you have already seen a slide like this or very similar. What this essentially shows us is what changed after Java 10. And so after Java 8, Oracle decided that they would no longer provide public updates unless you either weren't using it in a commercial environment, so only a developer, or you basically paid them a fee to use it. Now, looking at Java 9 and 10 and onwards, we'll see that that period has cut right down. So whereas Java 7, 8, even 6 had very long LTS release cycles, going forwards, what Oracle has decided to do is do lots of short quarterly releases and then run a single LTS release that gets commercial support for a longer period. So if we go up the release train, we'll see that Java 9 and 10, which weren't LTS releases, were only free and available for 6 months. And then basically what we see with Oracle JDK is that all of those started becoming not free in production. You can't download them from Oracle's Java page anymore if you're using them in a commercial environment. So you can only use Java 11 and onwards from Oracle if you're basically developing on your local machine. So as I mentioned earlier, we have a whole different suite of vendor distributions. And so I wanted to just quickly go over the differences between the vendors. So first in, and we've put this in green because we're slightly biased, there's AdoptOpenJDK. That is essentially a group of organizations that have come together and created this binary in the open. Some of the names you can see there, IBM, Microsoft, but it goes a lot further than that. We have Red Hat, we have Amazon. Some of the largest Java vendors in the world are working on AdoptOpenJDK. But Adopt isn't your only option. You can download Amazon Corretto. Azul has been making Zulu for a very long time. It's a very stable binary. Belsoft Liberica, a whole lot of Linux distros produce OpenJDK binaries, and we'll cover them later. Red Hat, again, has been maintaining Java for a very long time. They are already in charge of OpenJDK 8 and 11, and so they produce a very high quality build. There's also Sat Machine and Alibaba Dragonwell. So as you can see, Adopt isn't the only option. There's a whole set of companies out here that are currently building OpenJDK, but we're going to primarily focus on AdoptOpenJDK. Now, I'm just going to check in. Is Hendrik back? Nope, I'm not hearing Hendrik. So I'll carry on then. So we're going to look at the OpenJDK workflows then. So here we have an example of OpenJDK 8. And what we see is that a new feature goes into the OpenJDK 8 branch. Now, those branches are essentially all there in parallel. So there's an 8 branch, there's an 11 branch. And as those fixes get put in to OpenJDK, we'll see in red, there's a whole set of security fixes that get slotted in at the same time. So when we look at how the vendors then use that, we can see that the... are you here, Hendrik?
Hello?
Hello, can you hear me?
George, now I can hear you, and it sounds good. So I'm on another PC.
Excellent.
The first one, I don't know.
Excellent. We're covering the OpenJDK workflows, Hendrik, if you want to take over.
Yeah. Okay, yeah. So, yeah, to be true, I don't know what you already said, but...
I just turned to this slide, so I was just covering about security fixes and new features going in and how vendors are picking them up.
Yeah, perfect. Okay. And I think what is special on this slide, what we can see here is that vendors who want to provide a long-term support for a Java version maybe even a longer support than you have basically or had basically, for example, from Oracle for free some years ago for Java 6, 7, or 8. What all of them did is that they forked the repository and worked then in a closed repository on the branch. So what vendors then did in such case, it's that they do not fix things in the OpenJDK repository, but fix things in internal closed branch, which means like at the end, each fix has to be done by each vendor. And on the next slide, I think we can see this quite good, because what we have here is, so after Java 8, Java 9 was the next release of Java. And again, this was created out of the master. And I don't know if George said this, but this is a very simple view on the OpenJDK project and the structure. So when talking about Java 8 and 9 and 11 and maybe 6 and 7, it's not like described here that it's just a branch like you might know from GitHub. In general, this is much more complex in OpenJDK, but I think, so you can think about this workflows, and I assume a lot of you are familiar with this workflows, and at the end, it's the same what happens here. It's just more complex with more repositories and so on. But what we can see here is that security fix, so someone opens an issue and says, okay, I don't know if I do this and that the security manager, for example, in Java is broken and everybody can have root access on the file system. I don't know, something like that. And this is then fixed in the OpenJDK. And what happens is, since this is a security fix, this is then backported or merged to all Java versions in the OpenJDK that are currently supported. In the worst case, this is just one, like here in the example 9. And so the fix then we have on the master for future Java versions like 10, 11, 12. And it's fixed in the open and still supported branches like 9. And what companies and vendors now do is they take this fix and merge or re-implement it into their closed internal branches. And while, yeah, I think you've often merged things, but so this is not as easy or often as easy as it sounds, because so let's just think about, let's assume we have Java 7 and 8. Java 8 introduced lambdas, and so maybe the hotfix was done on the master branch by using lambdas, so you cannot just merge this one into Java 7 because the language feature of lambdas is just not there in Java 7. So often you really need to re-implement the feature as a vendor in your private branch. And this could really end in different Java versions from Java vendors that from time to time really behave differently. And why they behave differently is, this is with the security fixes is only one point why they can behave differently. Another point is that some of these vendors that provide long-term support for Java releases in closed repositories not only fix security issues or backport security fixes into their branch. From time to time, for maybe a paying customer needs a specific fix, needs a specific feature, and then they maybe implement this feature into the vendor-specific branch. Maybe there's something that came to Java 9, a fix for a swing component, which is not defined as critical or a security fix, and someone says, hey, we pay for LTS, we want to have it in our Java 8 LTS, and I give you $20,000 additional dollars to have it next month in our Java 8 LTS. And then you really have different versions of Java 8 out there, which, yeah, definitely is a problem. Happily, this was the case when the new release train was announced, and when like an end for Java 8 and a quite fast end for Java 9 after 6 months was announced. a lot of people, which includes me, were frightened that something like this will happen and that this at the end will be the default case for Java. Happily, it's not, because on the next slide, we can see what happened. Next to all these vendors that have a closed branch, closed repository for the long-term support, there's at least one company that do not have it, which in this case, I mean, it's not written here, but it's Red Hat. And what Red Hat does is, instead of having a closed branch where they backport and merge all these features, Red Hat has committed to do all this work in the OpenJDK, which means that Red Hat merges all security features into the OpenJDK Java 8 branch, and by doing so, keeps this branch alive. And they are not only doing it for Java 8, they are doing it for Java 11 too, which means like the 2 LTS versions of Java that are currently out there on the market have, at least in the sources, right, in the OpenJDK branches, all the important security fixes in it. Hopefully the same will be for Java 17, which is the next LTS version. But for now, we can say that for Java 8 and for Java 11, this happens. And this is quite a really important step that Red Hat committed to do this, because based on this, we have an open source version or an open source branch of the Java LTS versions in the open for free that everybody can access and use to build Java versions that contains all the security fixes. And this is a critical point when talking about the binaries that are provided by AdoptOpenJDK. And if we go to the next slide, we again see the release train that was shown before, but thanks to the work of Red Hat, now we can say that we really do not only have the 6 months versions open source and maintained and provided with security fixes, but LTS versions like Java 8 and Java 11 too, and this for several years. So we hope that Java 11, I think it's 2024 or something like that, that Java 11 will stay as an LTS version. Okay, that's it with the general workflow of the OpenJDK and the Java release train. And this has some, or based on all these changes and based on the new release train, some other changes in the OpenJDK and the Java binaries changed. So some years ago, like in the area of Java 6 and Java 7, normally when you needed Java, what have you done? You went to the Oracle web page and downloaded the JDK or the JRE, right? And installed it on your system. Maybe you had Linux-based servers where you used OpenJDK-based distribution that was built by the provider of the Linux system, like Ubuntu, for example. But for everything else, you normally downloaded the Oracle JRE or JDK. And since we all know Java is open source, Oracle did, I would say maybe some tricks here. Because what you can see on this slide is on the left, in general, the OpenJDK. In an example, in the version 8, and everything that is part of the sources of the OpenJDK. And on the right, you see the binaries that you download from Oracle when you download Oracle JDK 8. And here you can see that this contains more than you can find in the OpenJDK repository. And first of all, you can think, wow, that's perfect, that's good. I download it from Oracle and get some sugar on top. And to be true, first of all, this is right, because what Oracle did here is that they bundled some nice, interesting, and really useful tools together with the Java runtime that was built based on the open source sources from OpenJDK. Examples are Flight Recorder, Web Start, or Mission Control. The problem here is that all these tools, Flight Recorder, Web Start, Mission Control, and even some other things were not open sourced, which means like this is closed source that comes from Oracle. And if you use one of these features with Java 8, there was just no possibility to switch to another Java vendor or just use a somehow built OpenJDK distribution, because you depend on tools that are closed source and only provided by Oracle. And for a lot of Java developers, this was not really clear that this is the case. And this created a lot of issues, right? Let's have, for example, WebStart as, or let's have WebStart as an example. So what Oracle did is they announced some time ago that they do not continue to provide WebStart in Java 11. WebStart is already gone. So even if you download the Oracle JDK L11, there is no WebStart in it. So WebStart is only in 8 or earlier versions. But if you depend on GenLP and WebStart, you cannot easily upgrade to Java 11. To be true, you can, because AdoptOpenJDK has a solution we will see later. But this is a general case. What Oracle did is what we see on the next slide, that they, for the new release train, did something quite good, because they open sourced some of the components. Examples are Flight Recorder or Mission Control that are now part of the OpenJDK. And based on this, the distribution that you can download from Oracle is with Java 11 already quite similar to any other distribution. There are still some exclusive Oracle things in it, but I think with Java 11, this was a specific garbage collection and some additional small things. And starting from Java 12, I think it's really completely gone, and Oracle do not provide anything specific on top. They could do all the time, like others like Azul could do too. Some do it, Oracle did it, Azul does it too. They have a custom garbage collection that is only in the Azul JDK. But a lot of things were just sponsored to the OpenJDK and are now part of the open source project, and therefore can be provided by any distribution. At AdoptOpenJDK, we, for example, provide mission control for download, that you can easily use it with a JDK, or we even provide the Eclipse integration that you can download from our adopt page and just use it. Okay, that's the state of the JDK, the difference between Oracle, OpenJDK, and so on, and the new release train. And I think, all the things, some of them helped AdoptOpenJDK to provide free binaries, like Red Hat doing fixes in the open, or Oracle providing things like Flight Recorder and so on to the OpenJDK. But at least this is the important part of the legacy of AdoptOpenJDK, and why we as AdoptOpenJDK can provide all the things for free for you with LTS support and so on. And on the next slide, I think this was the last one. Now we will talk about AdoptOpenJDK and the history of AdoptOpenJDK based on all this information. And I will give up to George, who will give an overview about the AdoptOpenJDK project.
Cool. Thanks, Hendrik. So I'm hoping that that's given everyone a reasonably good introduction into OpenJDK and the current state of things and where we are with branches and who's maintaining things. So let's dive into AdoptOpenJDK and start talking about the history behind it. So we go back a long way to approximately 2003, and we actually started a Java adoption group. It was a group of people that the London Java community helped back, that had a goal of helping people contribute their patches upstream It's not necessarily the easiest process to get your fixes into OpenJDK. It's got easier over the years, but it's not exactly an easy process still. So this project was put together to help people do that. But it wasn't until 2016 that things really started to change. And that's when IBM created a project called Get OpenJDK. The goal of Get OpenJDK was, and as you saw on a previous slide, there are a whole host of Java vendors out there, all different companies doing their own thing. And the issue we have around this is that there are so many different companies building OpenJDK that we start to see little differences between them. For example, there may be a packaging difference, or the folder layout may be slightly different, or the version that they're building is slightly different. And so what people were starting to complain about was that an Oracle Java binary may not perform in exactly the same way as, for example, a distro Ubuntu OpenJDK binary that you get with an apt install. And so the idea of this project was to consolidate the ecosystem, and I guess try to sort of remove all of the vendors and bring them together. And so we put together this project, and it slowly grew. In 2017, IBM donated the entire project to this adoption group. And that's when AdoptOpenJDK, as we all know it, really was founded. Quite soon on, so we're going for another year, we hit 1 million downloads, which is a pretty major mark when you think about how many other vendors are out there. And when we went forward to 2019, you can see that number has sort of grown rapidly. We were at 30 million downloads, but actually the more important number here is 23 sponsors. Now that's important because it shows us there's more and more companies getting behind the project and supporting it, whether that's financially, with expertise, with personnel that they can throw at the project. It all helped it grow. And if we go forward one more year, you'll see we're at, well, I've put 160. Unfortunately, we're not. We're actually at 170 now. So we only made these slides a few weeks ago. So it's growing very, very quickly. And I guess the key thing that's come of 2020 so far is the announcement to move the Adopt project into the Eclipse Foundation. So let's cover that briefly. So if people didn't see the tweet went out, I think it was the 19th of June. I'm just looking. Yes, it was, where we announced that we would formally take AdoptOpenJDK and bring it into the governance of the Eclipse Foundation. There were several reasons behind doing this. One of the main reasons is that today, Adopt is supported by a very small Java user group, the London Java community, and they support us financially and legally, which is a huge burden for any Java user group. So the kind of key goal here is to pull it away into an organization that really knows how to deal with these things. But we also wanted to bring it to Eclipse because they're one of the best foundations out there for managing particularly Java-related projects. And they have a huge amount of expertise in the area. And so the entire project will be moving. There's no sort of exact public ETA as such, but it's certainly going to be in the next few months, so keep an eye out. What it means, just very briefly, for the current sort of governance setup that we have, the Technical Steering Committee, which is perhaps incorrectly named Technical Steering Committee, even though it does non-technical things as well, will be split into a PMC, Project Management Committee, which will handle all of the project and technical related issues. And we will also be founding a working group, which will have its own steering committee or committees. And that's where companies that want to get involved with the project and sponsor it and join that working group can come and play. So let's go back to AdoptOpenJDK and talk about why AdoptOpenJDK makes sense. So the main thing I always say to people is we really are the place to get binaries by the community. The binaries are completely business ready. We have a very broad, if not the broadest platform coverage. We cover things from ARM to Mac to funny mainframes. I'll cover that later. They are professionally tested by an incredibly large test suite, which I'll let Hendrik cover later. We have a really clear support policy. It's completely transparent. Anybody can go to the website and read our support page, and we try and make it as free to use as possible. We're backed by major vendors in the Java community. As I mentioned, we have 23 sponsors, and a lot of those are the key vendors in the community. And we're already at, you can see I've updated this slide, we're at 170 million downloads, and that's growing every single day. One of the key goals here is that we remain open and transparent. We always have been. Everything we do is in the open. The technical steering committee has public meeting agendas. All of the project is open source, except for a very, very small set of infrastructure, secret repos. Everything that we do happens on GitHub and Slack. And so it's very easy for anybody to come along and get involved and see what's going on and work out where they could help. So running a project that has over 170 million downloads can be a technically challenging task, to say the least. To kind of put things into perspective here, we have over 170 million downloads. We have 200 or more dedicated machines running all the time that we have to patch, add dependencies to, maintain them. And we have, I think, 106, it may even be more than that now, GitHub repositories that all have security vulnerabilities that need ironing out and so forth. So it's a pretty huge task. So I'm going to quickly go over the build and binary pipeline. So the way that we build, we have, we have a build and test pipeline. So when we kick off a build, we use Jenkins to handle all of this, and I'll cover that in a second. We get the OpenJDK variant source repo. Now, we tend not to get that from Mercurial. We actually mirror those Mercurial repositories into GitHub for speed reasons. We then choose which branch to build from. That can be dev, because sometimes we have a small set of patches. For example, on JDK 8, we have a whole load of notarization patches from Mac that haven't been upstreamed. Or it's normally master, which is essentially a clean mirror of what's going on in master. We then take that and we put it through our build, test, and deploy pipeline. So we build it via CI, AdoptOpenJDK.net. That's our Jenkins instance. I'm getting a lot of background noise here. Is someone able to mute? I'll let someone have a go. Anyway, so we then run our tests. They get run also through Jenkins, and then they get deployed and pushed into the available orange box, which is not only just the website, but we also have an API that can be used. And Hendrik's going to cover that later. What is interesting here is the red dot sort of dashed line, which represents approved third-party OpenJDK binaries. The only example we have today is the Red Hat OpenJDK upstream binaries that are provided to the project. They get put onto the website and they get put through our entire test and deploy pipeline before they're made available. So as I mentioned earlier, we have a Jenkins CI. I must admit, I picked a green section to make our project look better. There are some red builds, unfortunately. But we're doing a pretty good job here. As you can see, we have a job folder for every Java version, well, that's 8, 11, 13, 14, 15. And as you can see, we have an individual job that is represented, that represents each architecture and OS combination. So whether that's Linux Arch64 or Mac x64. So our Jenkins is completely public. Anybody can go to it. I mentioned earlier, the link is ci.adoptopenjdk.net. So if you're ever looking for the absolute bleeding edge and you can't pick up the Nighty, it's worth having a look at our CI build to see if you can pick one up even sooner. In terms of the VMs that we support HotSpot, which is what just about everybody expects in an OpenJDK binary. It's certainly the most widely used VM today. It's what comes as default in Oracle's JDK. It's shipped as part of the OpenJDK source code, and it is suitable for all workloads. If an application is written for Java, it's very suitable for the HotSpot JVM. Now, unfortunately, as an ex-IBMer, I do have to also cover Eclipse OpenJ9. It can be a good alternative to HotSpot. It isn't always a good alternative. AdoptOpenJ9 comes from the IBM's open source J9 binary. It's essentially OpenJDK class libraries, and they just rip the HotSpot VM out and put in their own. And it can be useful for some cloud or container workloads. There are benchmarks to suggest it can be more efficient to run. Now, as I mentioned earlier, we have a really broad range of supported platforms. We have all the common ones like Windows and Mac and AIX and Linux. But the interesting one here is RISC-V. We support Solaris, Oracle Spark, and even ARM and other embedded chipsets. So we really do have a really broad range of supported platforms, and anybody that has any of these can go and download a binary. Now, as I mentioned earlier, all of our sources, all our builds are based on OpenJDK. We're not our goal is not to fix Java and swap it out with some other new GC compiler and enhance it in any way. We are looking to build the pure OpenJDK binary. As I mentioned, we mirror those mercurial repos into GitHub. And we do have a very small set of additional build steps for things like miniaturization on macOS. So I think I'm now going to hand back over to Hendrik, who's going to cover some of the test stuff.
Okay, cool. Yeah, so based on the things we have seen from George, or that George described, in theory, every one of you can build your own JDK. Because based on the build scripts that AdoptOpenJDK provide, and based on the Open Jenkins, where you can see how these build scripts are configured and called, in general, you can just set up a Jenkins on your own, maybe on your laptop, and build your own JDK. That is possible, and you can use this JDK if you want to. Well, does this make sense? I don't think so, because still when you build it on your own, you cannot be 100% sure that this JDK that you just built, once perfect, once performant, has really included everything that you need. And Java is really complex, right? And normally you need it to run critical business applications. So the JDK that you use for such applications must be enterprise ready, must be approved for production, and yeah, the JDK that you just built on your laptop maybe is not. And to check all the builds that we create at AdoptOpenJDK, or all the binaries that we build at AdoptOpenJDK, the project contains a large test suite, which is called Aqua. It's an open source test suite to test Java binaries. And what does this test suite does is that it consists of a lot of different tests and even test types, as we will see on the next slide, that are all part of the open source project and contributed by some companies, like, for example, IBM, who contributed the initial structure of this test suite, and even some of the test groups that were executed there as open source tests. But next to this, there are some tests that come from other frameworks or applications, like Tomcat, for example. And since, like everything else that we do, the Aqua suite is 100% open source, this is not a test suite that was designed to test AdoptOpenJDK binaries, but a test suite to test any OpenJDK-based build, which means like any OpenJDK vendor can use this test suite and run it against their own builds to check that the builds are performant and can just run all the tests and things like that. So as already said, we have a lot of tests here. Let's have a look at some numbers. What a lot of tests means. I mean, are a lot of tests 200? Are a lot of tests thousands? What we see here is kind of metrics where we see, okay, we currently build binaries for, roughly 55 to 60 platforms. Now you can think, what? Wait, there's Windows, there's Mac, there's Linux, and maybe some special Linux system. Why do you have that much? As you can see here, it's multiplied with the runtime types. If it's an HotSpot-based JIT or if it's based on OpenJ9. And for OpenJ9, we provide two types. We provide the regular type and the one with large heap support. So, and based on this, you have roughly like 60 different platforms. Next to this, we support in general 6 Java versions that will be built mostly with each Nighty and with each release. That are the current LTS versions like Java 8 and 11. Then the current Java version, which is, for example, 15. Then you have a future version that will come in future. And from time to time, you even have feature branches for specific functionalities that will be introduced to Java in future for bigger projects or for bigger parts of Java that will change. Maybe you heard about things like Project Valhalla or things like that. For all this, you can get extra bits. And now the test number, I think this is even not updated anymore, but it's roughly about 250,000 tests, which means that for each build round trip, like for all the platforms, for all the different Java versions, and this is really done in the Nighty, we run about 87 million of tests. As you might know, this is not working anymore on your laptop. For this one, we have a quite good cloud infrastructure. George will say something about this later. But let's have a look at this 87 million tests, how they look like. So as already said, we have this test suite Aqua. And what this does, it defines groups of tests. Currently, we have 6 groups of tests, which are the OpenJDK, functional system, external, perf, and JCK groups. So I don't want to go deep into each of the groups, but let's give some examples what you can expect in those groups. So from OpenJDK are some tests that came from the OpenJ repository. So the OpenJDK already provide, for example, some unit tests, things like that, that will be executed. Then we have, for example, the perf, which are performance tests. So what happens here are benchmarks that are executed to check that the binaries are still performant enough to fulfill some, predefined run times for do things and just check if the performance of the build still fits. The JCK group is interesting too because this is a predefined group that can be used to test if binaries fulfill the Java TCK. While at the AdoptOpenJDK, the binaries are currently not executed against the Java TCK. The Aqua suite already provides these groups and provides everything that is needed to execute it, so that Adopt can execute it later, and other providers can already execute it today if there has a TCK license. Another interesting part is the external group, because this contains a lot of tests that come from external projects. In this case, this is really one of the big groups here, which includes like 125,000 test cases. So, and here we see it's like 12 plus apps and 5 microprofile TCKs. What does this mean? This means, so when talking about the Eclipse microprofile, which is just a specification or contains a lot of different specifications, how to create microservices. All the specifications provide a TCK, a test compatibility kit, so that implementations like Whitefly, like, I don't know, Payara, so all these enterprise servers that provide microprofile support can be checked that they're implemented the right way. And what we are doing here in the test suite is executing all these TCKs against our built binaries. And next to this, we see this 12 plus apps. This contains apps like Tomcat or like the DerbyDB. And what we are doing here is we're running all integration unit and so on tests that are provided by this tools or framework, Tomcat, for example, and run it based on our JDK and check that on our JDK, these tests are still all green. And based on this, we will really have a lot of different tests, a lot of different test types, and can really check that the binaries that are distributed by us are 100% enterprise ready. On the next slide, we can see an example how this external test, for example, might look like. So in general, what Aqua does is executes all the tests. Oh yeah, and maybe this is interesting. I haven't mentioned this. All the test groups can run in parallel. So which means we do not need to run all the tests one after each other. We can do a lot of asynchronous things here by running all the functional tests in parallel to the performance tests. And we have different setups how tests can look like. Some, for example, use Ansible, where a system is set up by Ansible and used to run the test. Another example that is shown here on the slide is using Docker. And this is, for example, used for the tests that came from Derby. So what we are doing here is the Aqua suite, when running the Derby tests, sets up a Docker container that copies our built JDK into the container, installs something like, for example, Maven, then checks out the Derby repository in a predefined tag, which normally for us is the latest stable tag, and then builds Derby already based on our JDK. So we already use our JDK that we've copied into the Docker container to build Derby. And then we execute all the tests of the Derby repository, all the unit tests and so on that are part of the, I don't know if Derby is at GitHub, maybe at the GitHub repository of Derby. And yeah, maybe it's, I don't know if Derby is JUnit, let's assume it's JUnit, and then correct all the JUnit results. And all these corrected results are taken back to the Aqua test suite. And so what the test suite does is like executing all of these tests and tests group, like for example, we can see here on the slide, then correcting all the test results of this 250,000 different tests, and then provide a global test result for a Java binary based on all these tests. Yeah, and with the groups even in parallel. That's about the tests that we provide and use on our own to, yeah, just offer enterprise-ready Java binaries or OpenJDK-based binaries. So what we've seen so far are some of the projects that are hosted at AdoptOpenJDK. For sure, most of you know AdoptOpenJDK based on the Java binaries. Now we learned about the Aqua suite that is a huge part of Adopt2, the test suite that we provide of an open source tool, but Adopt has some more projects that might be interesting for some of you. Here we see a list. George already mentioned the Red Hat upstream builds, so the binaries that are built from Red Hat out of the OpenJDK. We host them for download. We do not build them, but we host them on the AdoptOpenJDK web page. Yeah, we have Aqua, as already mentioned, and now we have here, JDK Mission Control. I already mentioned this, that we provide the binaries, and now we have here 3 additional things, ICT-Web, JITWatch, and JLink Online. So let's say some words about each of them. ICT-Web is an open source replacement for Java Web Start. This came from Red Hat. So Red Hat contributed this to AdoptOpenJDK, and this was an early implementation of Red Hat based on the JNLP spec to provide an alternative to Java Web Start. But Red Hat stopped investing into this topic, and so they promoted it to AdoptOpenJDK, and now we take care of this. I'm one of the maintainers of this project. We even built this and integrate this in our Java 8 Windows binary. So if you download an AdoptOpenJDK 8 binary for Windows, you can select in the installer that you want to have ICT-Web installed, and based on this, you just have a Java WS executable that behaves like the one that you get from the Oracle JDK. Next to this is ICT-Web is the base of the open source tool OpenWebStart, which adds some sugar on the WebStart functionality and can be downloaded for free too. But this one is not part of the AdoptOpenJDK. JitWatch is a tool for analyzing and visualizing the just-in-time compiler of the HotSpot VM. And JLink is a service that you can use to create JLink-based binaries on the fly. So JLink is this new tool that was integrated in or introduced with Java 9 that helps you to create Java runtimes that only contains modules that you need. To, for example, if you want to run your application in a Docker container, have the Java runtime as small as possible and remove all the modules that you do not need for your specific application. And JLink Online is a service, an online service that we provide. More or less, it's a REST endpoint, and you can call it by defining what Java modules you need, for what operation system you need it, based on what Java version you need it. And this then internally on the back end creates a specific Java version for you based on our AdoptOpenJDK versions that contains only the versions that you need and provide it directly for you as a download. So these are, a handful of additional projects that we have hosted at AdoptOpenJDK and that we maintain. Once we move to Eclipse, maybe new will come to it. Maybe some of them won't move to Eclipse in a first version, we will see. But this is the current state. But next to our move to Eclipse, we have some additional things on our roadmap that are planned for the future. And therefore, we have a technical roadmap where George and I want to give a short introduction to. One thing we are working on, and maybe this should even be on the last slide because this is something that we just host, is the AdoptOpenJDK API, which is an API that helps you to dynamically download Java versions. And for this one, we have a Swagger UI that makes it quite easy to use and see what you can do with it. And so let me check if I can share my screen to give you an example of that. The stream is limited to 6 video sources. Let me see. Okay. What happens here? No, not this one. I think now you see my whole screen, but I have 2 screens attached. Where can I? Do you see my screen now, or what do you see? Do you see anything?
Yeah, I see your screen.
Yeah, we are seeing your desktop here.
Let me see. Now you see the Chrome browser?
Yes.
Okay, perfect. Okay. So let me see. I don't know why it's a little small. Let me. Yeah, I have some tabs open. I mean, we have a web page, right? The AdoptOpenJDK.net, where you get all the information, can download our versions. But as said, we have an API for this, which is the Swagger API. But before going to this one, George already mentioned it. Under ci.adoptopenjdk.net, you can access our Jenkins, where all our builds are running. And if I just click here to all, you can see that this is really a huge list of build jobs that are executed onto Jenkins. And I don't know why it's so slow at the moment. It's loading. Let's go to the next one. So it's just a huge list of jobs. Next to the Jenkins, we already said that we have around 150 million downloads. I just check it. It's like 177 million downloads. We have a dashboard that you can check, or that you can use to check how many downloads we have, what version has been downloaded. So if I, for example, now go into this total view, I can check, okay, which are the downloads of Java 8, of Java 11, and then in Java 11, I can, I don't know why it's not, yeah, here we go. Even check which update is the one that was downloaded the most, like here, Java 11.0.3, and then I could even go one level deeper to see the downloads for all the operation system and so on. So you can download it on your own by hand on our homepage, but as said, we have an API for this too. And this is maybe, for example, interesting if you want to roll out a Java version on your company for all machines, or if you want to use AdoptOpenJDK binaries, for example, in a Docker container. And for this one, we have an endpoint. And let's have a look at the binaries endpoint. And here you can already see how the REST endpoints are defined. So we currently have version 3 of our API, and under the binaries, we can download just a Java binary. Oh man, what's up here? Come on. Open yourself. Goes up and down. Okay, here we go. Yeah, I mean, I can just try it out now and define an endpoint. Okay, I want to have it for 64-bit, and I want to have Java 11, and I do not want to have large heap size for OpenJ9. I want to have a regular one. I don't want a JRE. I want a JDK that is HotSpot based. And what's wrong here? Come on. Yeah, I don't know what's happening here. It looks like today I do not have any luck. So I mean, it's in the browser. All right, it's a combo box, so normally you can select to have general availability release, which is normally the one that you want. If you want to test a specific feature, like a feature that is coming to one of the next Java versions, you could even use an early access, but normally you don't select if you want to have one of the AdoptOpenJDK binaries, or if it should be one of the upstream binaries that are built and provided by Red Hat. And if normally everything would %, and you execute it, then you would even see the URL and would see how you can download it.
Okay. Hendrik, I think your battery is. I think we've just lost Hendrik. Okay, well, hopefully he'll get back to us in a minute. He's making a habit of disappearing today. Let me restart my screen share anyway. So here we are. So hopefully people can see this again. So Hendrik covered the V3 API. There's a few other things we have on our roadmap. One of the really interesting things is dynamic infrastructure. So as I mentioned earlier, we have over 200 dedicated machines running all day, every day in our build farm that we have to patch and maintain. Those could be a server running in a cloud provider. They could even be a server running like a Raspberry Pi or something on someone's desk. And so it's pretty complicated. There's a lot of machines knocking around that we have to look after. And so the idea is we want to pull away from having all of these static machines and move to a more dynamic setup. So what I mean by this is that a job would be triggered and it would then go to a cloud provider, for example, IBM Cloud, Microsoft Azure, Google Cloud Platform, AWS. It would pick a machine that was suitable. And then what it would do is, rather than installing all of its dependencies, which takes a long time, we'd use Docker. So we have a predefined build image in Docker. And then that Docker image basically gets run and we enter it using Bash. And then we would kick off the build in the exact same way as before. Now, I'll cover the main kind of benefit behind this in a moment. But what that really looks like is it means that we can pull together a lot more builds a lot faster using concurrency to push things out quickly. I had to include a meme here. This is one of my favorite ones about Docker. So I hope a few of you enjoy it. But it's all about, if you want to ship, if it works in your machine, ship your machine. So anyway, going back. So here we are. There's two big reasons that parallelization are beneficial to us. The first one is that we can test pull requests and changes faster and across a broader spectrum of platforms. So we can spin up, let's say, 100 machines at the same time rather than relying on those three, use them all for 30 minutes and then tear them down and get a much smaller build than having 6 machines running 24 hours a day. This is also useful where it comes to tests because we can actually make our tests run faster. As you saw, 87 million tests, that takes a long, long time. And so what we're looking to do is break that up into smaller suites and get more machines to execute them at a faster rate. A kind of number to put on things here. Until recently, the entire Linux test suite took roughly 11 hours to complete. By using concurrent machines and lots of parallel nodes spinning up, we were able to pull that down to under an hour. So it's a pretty major difference here. There's a few other items we do have on the roadmap. There's a website redesign. I don't know if anybody's interested in website development here, but it needs a bit of polishing, if I'm honest. As Hendrik mentioned earlier, we have JLink Online, which is a really exciting tool for getting lightweight binaries rather than the full fat. And we're also doing a load of work in GitHub Actions. As of yesterday, I don't know if people saw the announcement, but AdoptOpenJDK is now the default JDK installed in GitHub Actions. But we're also doing a whole lot of actions around running the Aqua test suite so that any JDK developer can come along and test their changes really easily in the GitHub environment. At this point, I always like to say a quick thank you to all of our sponsors. We really wouldn't be able to run without them. So here they are. If people are interested in becoming a sponsor, then please do either contact Hendrik or myself, or we do also have an email. You can email sponsorship@adoptopenjdk.net. I like to end on this slide here. This is all about the community. We have over, I think we have over 500 contributors regularly to our project now. It's an ever-growing project, and I'd love to work out a way of getting more people involved. So please do, if you're interested in contributing to the project, get involved, join the Slack channel, go to our GitHub page. You can follow updates on Twitter and our website. There's so many things to do, and so many of them should be easy to pick up. Now, I'm not sure if Hendrik's back yet, but I'll leave it on the any questions slide. And so I'm not sure how I think we just answered questions in the chat area. I think that's right. So I'll leave this slide up for a few moments. And if anyone has any questions, then please do type away.
Evet arkadaşlar, soru var mı? Any questions?
I'll take that as a good thing. I think that means that we've taught everyone everything there is to know already. I think Hendrik's asking to be re-added. Are we able to re-add Hendrik?
We handled it.
There you go.
Okay.
Perfect. Cool. Okay. Well, there's no questions, Hendrik. So I guess on behalf of us two, I'd like to say a big thank you to hearing us. Please do, if you have any further questions that you come up with later, do drop them on Slack. Particularly around things like the move to Eclipse. Generally, people are quite interested in that. So we'll hang around for another few moments just in case there's anything. But otherwise, thanks for hearing us, and hopefully we'll talk to you again soon.
Yeah, thank you, Hendrik and George. So we don't have any questions from our attendees. So thank you for your presentation again. Bye.
Lovely. Thanks for having us then. All
Thank
the best.
you so much for everything.
Thank you very much. Thank you.
Thank you.
Okay.
Thank you for having us.
See you again.
See you. Bye-bye.
Bye-bye.
Bye.
Bye-bye.